Hello, welcome to 3.4, Variation and Multivariable Functions. So variation, we have direct variations, the first one we'll talk about. Y varies directly as the nth power of x. You may have seen the variation before, you probably have, but maybe not with the power. So y varies directly as the nth power of x, or y is proportional to the nth power of x. These words mean something. That means y equals k times x to the n power, where k is your constant of proportionality. It's just a constant. It'll be a number. It could be a 2. Oops. It could be a 3. There we go. So, example 1, find the mathematical model for the following verbal statement. V varies directly as the product of 4/3 and r cubed. That would just be V equals, varies directly, K, varies directly, you got to have a K in there, 4/3 r cubed. So, you can write V equals 4/3 K r cubed. Next one, solve the variation problem. Suppose that y varies directly as the cube root of x. So that means y equals k times the cube root of x. That's what those words mean. That translates directly. Then we have two cases. Y is 75, so 75 equals k times, when x is 125, times the cube root of 125. So 75 equals k times 5. And that allows us to solve for k. We divide by the 5. So k would be, anyone? Is that 15? Now it says, what is y when x is 128? So we have the model y equals 5 times the cube root of x. So y equals 5 times the cube root of 128. So what is y going to be? $75.595. That's a decimal approximation. That's direct variation. Let's talk about inverse variation. Y varies inversely as the nth power of x, or y is inversely proportional to the nth power of x. What that means is this. That translates into y equals k over x to the n power. Suppose that y varies inversely, so y equals k over, inversely as the cube of x. So have an x cubed down here. So y is 0.005. 0.005 when x is 10 equals k over 10 cubed. So 0.005 equals k over 1,000. Multiply both sides by 1,000. 1,000 times 0.005, so 5 equals k. So y equals 5 over x cubed. And it says, what is y when x is 5? So y equals 5 over 5 cubed. 5 over, well, I could just reduce that, couldn't I? 1 over 5 squared, or 1 over 25. Okay. Go on to the next page here. A record store manager observes that the number of CDs sold seems to vary inversely as the price per CD. If the store sells 840 CDs per week, when the price per CD is $15.99, how many CDs does he expect to sell if he lowers the price? So he says it varies inversely. So as the price goes up, the number he sells goes down. As the price goes down, the number he sells goes up. So if S equals the number of CDs sold and P equals the price, we have S equals K over P. It's an inverse relationship. So 840 equals K over, because he sells 840 when the price is $15.99. I know some of you are saying, what's a CD? So K that's a joke there, is going to be 1599 times 840. So K is going to be 13,431.60. So S equals 13,431.60 over P. The number you sell is going to be this number, that's our K, divided by P. So S will be 13,431.60 divided by 1499. So that's going to be 896.037 CDs. Well, let's just call it 896 CDs. Because you can't sell 0.037 CDs. So there's an application problem for inverse variation. I'm going to go on to joint variation now. Okay, z varies jointly as x and y, or z is jointly proportional to x and y if there is a non-zero constant k such that z equals kxy. If z varies jointly as the nth power of x and the mth, m as in Mickey Mouse, nth power of y, we write z equals kx to the n and y to the m. Suppose z varies jointly as the square of x, so z equals k times x squared, and the cube of y. There's our basic setup. And that z is 768 when x is 4 and y is 2. So 768 equals k times 4 squared times 2 cubed. So 768 equals k times, that's 16 times 8. Is that 128? Is that 2? I think it's 2. It is 128. We divide both sides by 128, and k is 6. So z equals 6x squared y cubed. Z will be 6 times 3 squared times 2 cubed, and z would be 432. Okay, we're going to go on to the last problem here. Force necessary to keep a car from skidding as it travels along a circular arc, skidding there, varies directly as a product of the weight of the car and the square of the car's speed, and inversely as a radius of the arc. So we're looking at force would be k times what? The weight of the car, we'll call that w, times the square of the car's speed, we'll call that velocity, v squared, over the radius of the arc, the square of the, just the inversely as the radius of the arc, over r. Okay, now we have some specifics. If it takes 241 pounds of force to keep a 2,200 pound car moving 35 miles an hour on an arc whose radius is 750 feet, how many pounds of force would be required if the car were to travel 40 miles per hour? So we're going to go with 241 to the force equals k times 2,200 pound car times 35 miles per hour, so 35 squared, over 750 foot radius. That's going to be 241 equals k times this product on top is 10,780 over, this whole thing reduces to be 10,780 over 3, I should say. So k is going to be 241 times 3 over 10,780. And that's going to end up being 723 over 10,780. So our force is going to be 723 over 10,780 times WV squared, all that over R. So our force is going to be 723 over 10,780 times 2,200 times 40 squared over 750. That'll give us 15,424 over 49, which is approximately 314.776 pounds. So that's the force that you need to keep it on the road, keep it from skidding. Okay. And that'll do it for 3.4. I hope you enjoyed that. Send me your questions. Thanks.